ಲ್ಯಾಪ್ಟಾಪ್ ಕನೆಕ್ಟ್ ಆಗೈತಾ?
ಹ್ಮ್.
ಇಲ್ಲ, ನನ್ನ ಫೋನ್ ಕನೆಕ್ಟ್.
ಅದು ಗೊತ್ತಾಯ್ತು ಲ್ಯಾಪ್ಟಾಪ್ ಕನೆಕ್ಟ್
ಏನಂತ?
ಏನ್ ಲ್ಯಾಪ್ಟಾಪ್ ಬೇಕಾ ನಿಮ್ಗೆ? ಯಾಕೆ ಬೇಕಾ ನಿಂಗೆ? ಏನೋ ಮಾಡ್ಕೊಂಡು
ಆಯ್ತು.
ಯಾರು ಕೇಳಕ್ ಒಂದ್ ಮೊಬೈಲ್ ಬೇಕು ಎಲ್ರು
ಏನೋ ಮಾತಾಡ. ಹಲೋ,
Good evening. Is it audible? Yeah, good evening. Is it audible? Anyone can just respond either through WhatsApp or by. Okay, thank you, Disha. See, the last class we are done in the class about what do you mean by priority queue. We already told the priority queue is nothing but depends upon the priority. I can delete an item from the queues. Either we have go for the higher priority or we have got the lower priority. There are two types of program can be write for the priority. See that we told in the last class in the classroom about what is the priority queue that. See where this priority we are using the application of the priority queue is. So it can. So it will be used in the Digistrans and Prince algorithm. So this Digistrans and Prince algorithm we studied in the module by the last chapter. We will learn the what type of algorithm you are using. In those algorithm, you are used for the finding the shortest path and also the minimum spanning tree for the construction of the graph you are using the priority queue. And it can also use in the CPU scheduling in the operating system to process, which is we have to give the highest priority to process that one, and also will applies for the bandwidth management used in the network for the router to manage the packet transmission. We have to use this, and also it will can apply for the event simulation for the managed for the event in the simulation based on their scheduling time. So we have given the prescriptive time. Whoever given the first preference, that person will be given the services to that. So these are all we are using the priority queue. See the same what we did for the last class in the class we have with the sequential queue, that is called linear queue, and circular queue we did it. Linear queue and circular queue we are using front end rear end as a pointer. We have to do how to deletion, how to add an element to the queues. Then in this, we have what type of operations can be done in the priority queue also. See, there are two types of operation. One is enque operation, again a deque operation. So what is the meaning of enque operation? We can add a new element to the priority queue with a given priority. Depends on the priority will be added into that. See how to add. You see, in the textbook, you don't have a complete detail about your program. But if in case if you have, you should be do it this much or enough. What is the priority queue? The priority queue can be done. Add an element to end of the heap. We are maintaining that heap memory. We have a stack memory, code memory. So in the operating system, we'll be getting to all those things. See, but now we are maintaining for the, whenever come to the priority will be look at the heap memory of that one. There are two type of heap property will be executed. One for the higher priority and another for the lower priority for that. So whenever I talk about the priority with that heap memory, so to add an element to the end of the heap, it's like a stack. Add an element to the end of the heap and restore the heap property, whatever I'm storing that, comparing the added element with its parents. What is its parents? The previous element. They restore the heap property by comparing the added element with its parent. If it can violate the heap property, then swap them. So whatever I'm adding that element, it is greater than, it is less than, depends upon what type of priority I am using. If you're using higher priority, that number is lesser than that given number, whatever is storing. Then if this number is greater than, if it is whatever already storing, that I have to do comparison. See, if it is the condition is not satisfied, then you have to swapping those two number. After swapping, it can able to load it into that queue. So continue this process up to the heap until the correct position is found and the root is reached. Swapping with the next element. The next element and the first element be comparison. If in case that both are the higher and lower will be swapping, and it will compare with the next of the root element. So according to that swapping between the all the levels of the numbers stored it in that heap memory, and finally it store the last number. If in case it is a maximum priority higher number, the last number will be stored the highest number and the first number will store the lowest number. It is also the reverse operation for the min priority. That is for the lowest number stored in the stack. See, according to that, it will do the addition of the number into the enque operation. See, what is the next one is a deque. This operation can be used to remove and return the elements with the highest max or in the maximum heap. See, that's a whatever I'm talking about the maximum element, I should be remove. See, there is a one more name is called the max heap. So whenever I want to delete a element from the priority queue, the minimum element I want to priority queue, then it is called the min heap of the priority queue. There are two names with the priority while deleting. So insertion can be done anyway, but deletion you have to do either in the maximum heap and minimum heap. Maximum heap will be used for to deleting in the highest number first, and minimum heap will be used for deleting the minimum number 2, 4, 6. Then 2 has to be deleted first. And if it is 10 is the highest number, 10 has to be deleted from the maximum heap. So how it will be do it? So because of that, we are giving extract either minimum or maximum. Replace the root of the heap with the last element in the heap. So whenever I want to remove from that one, the root is always will be taken the minimum number of the maximum number of that one. So replace the root of the heap with the last element in the heap, the next element. So reduce the size of the heap by 1. It's like a stack. What is the top value? The top value is always store the highest number in that one. Whenever I'm removing the topmost element from that one, and I'm reduce the top is equal to top minus 1. The same way, it is also do it in the queue also. They reduce the size of the heap by 1. And restore the heap property by recursively comparing the new root with its children and it's swapping it. After removing it, will check it out. Whatever the remaining elements are there, it is stored it according to that priority or not. If it is not stored into the according to the priority, what will we do? The swapping has to be done. Again, the highest element has to be stored in the root position. With the higher priority child in the max heap or the lower priority of the child in the min heap, it is stored. They continue this process down to the heap until the correct position found or leaf has to be reached. Is from the root, it will towards the leaf has to be continued. The priority queue should be remember one is enque operation for the addition of the element in the queue, and deque operation either I can be deleted from the maximum heap or it can be delete from the minimum heap can be done. The same way we have peak also. We already know what is a peak in the stack. Same concept in the priority queue also. Priority queue as is like a stack only. Okay. So this operation can be used to returns the element with the highest priority. See only returns. All of you observe the statement. This operation can use to returns the element with the highest priority without the removing it from the priority queue. I am not removing any element from the priority queue, but just I am returns what is stored in the top of that one. That is called a peak operation or the peep operation. So returns the element at the root of the heap. But it will do it in that deque operation. It will delete it from the queue only. Whenever deleting and change the position of the queue also by altering with the root value with the leaf of that one. Okay. And what do you mean by increase or decreasing key? So whenever I'm deleting, whenever adding, how the heap location will be increases by 1 or how the heap location will be decreases by 1. So depending upon the adding the element or deleting the element, the heap value will be up and heap value has to be down from the element. So that we call as an increasing or decreasing a key. This operation can be used to change the priority of the element in the priority queue. So what will we do? Locate the element whose priority needs to be updated. So which element I should be given updated. So update the priority of the element. I have already stack elements are there. I am giving a precedence. I am giving a priority to the lower number. See, whenever I am giving the priority to the lower number, once I am setting, I already store that element. After storing, I am giving a priority to that one. So whenever after storing the element, I am giving the priority, I need to rearrange all the elements what I am storing for that one. So how can we do all those things? That we call update the priority of that element. So by using, if the priority is increased in the max heap, that is for the highest element, or it can be decreased in the min heap. Increasing is nothing but I am storing according to the ascending order. That is when our highest number always stored it in the top of the stack. See what is decreasing is I am storing in the descending order. Then that is the lowest number has to be stored in the top of that element. See that it will do according to that. It can restore the heap property by heapifying up from the element. So there is a two types of operation. One is called, see whenever it is increasing the maximum heap, decreasing the minimum heap is called heapifying up. There are two types of operation, heapifying up from the element. So there is an opposite direction. If the priority is decreased in the maximum heap or increased in the minimum heap, restore the maximum heap called heapifying the down. This is with respect to the descending order. This is with respect to the ascending order. There are two types of operations are using. One we called heapifying up, another one is called heapifying up. So this is with respect to the priority queue. So this is the program, how I am doing the program for the priority queue. So for this we are using defining the maximum 100. So I have to define the structure of the priority. Because of that struct and items you have to insert the maximum size and priority queue. So I already told if it is not there in the root or it is not there in the parent of it is higher than or lower than, I have to swap between the two number. Because of that I am using swapping function, the normal C language swapping function. Void is a return type, swap is a keyword, int star a and int star b, the two parameter I'm passing. I'm taking a temporary variable, I'm swapping between a and b, I'm be doing. See, whenever you have to call either by epifying element to the function property for the during insertion. See, whenever I have to comparison with the element, whatever I'm adding, I have to do the priority queue, and whatever the index, I have to add that one. You have to check it out that one. We have to add if the index is greater, then they have to compare the index, and whatever the PQ is nothing but a priority queue variable. That way I'm accessing that index mine. I have to dividing because it is stored in the ascending order, descending order. It will be checking but off of the element. That whatever I'm checking that element is greater than or lesser than index. The comparison with if the condition is false, I'm swapping between those elements. or else I am calling epifying, I am storing that element into the position. See, this is for defining enque function to add an item to the queue. So where to add an element? Before adding element to the queue, I want to check the queue is full or not, the overflow. The priority, the PQ of size, the size is equal to the maximum, priority is queue is full, or else I'm incrementing the one position. It's like a top p of q of size plus plus. I'm adding to the value of that. Again, I'm calling the epifying function. So what epifying function will be called? Epifying function, every time you are calling to arrange all the elements in the stack or all the elements in the queue like a ascending order. To store the element in ascending order, or it's like a bubble sort, some sorting function I am calling. So that has to be do it in this function. Comparison with that element with the next element. Every I am dividing the array into half of part, comparing with the success of the two element, and which one is the highest and which one is the lowest. It is swapping those two number. Again, rewrite the array structure. So that has to be done by using epifying. Epifying up function has to be stored according to ascending order function. So that has to be done here. See, I have a one more function, epifying down function. For that, it has to be do for the descending order of the function has to be stored. The whichever is the smallest number, I'm taking the first index as the smallest number. Again, I have to comparison with either left side and right side. I'm making the half of part to compare with the left and right side. So whatever I'm storing the left index I should be compare with the less than of our item. If it is that item is less than, I am assigned whatever the smallest element that has to be assumed smallest. Again, I am comparing with the right side of that array. That has to be get a smallest, that right index has to be stored as the smallest. And what I want to comparison with our element with the smallest, to comparison the smallest with your current index. If it is not equal, I have to do the comparison of all those things. Finally, I have to call the epifying down. Epifying down function will have to store the number according to the descending order. For arrange the element in the descending order, we are using epifying down. See, then if you want to remove an element from the queue, see, whenever I want to remove the element from the queue, I have to check the queue is empty or not. How to check queue is empty? To check our queue is empty, then the PQ is then a variable I am pointing. It's like a friend and it's like a rare, right? PQ I'm taking the variable. The PQ of size is not equal to that one. Then priority queue is empty. I'm calling return minus. Or else that index, whatever that item stored in the index 0, that has to be stored in the item. Then I have to decrement the position of the queue by -1. See, because of that, I am doing P of Q of item minus minus of PAQ has to be this. And again, after deleting one element from that array or from that queue, I have to reshuffling that element which should be there ascending or descending order or not. See, because of that, again, I am calling epifying down with the PQ with the smallest index with 0. From the index 0, it can start again checking out arranging. So this is the return the item. So the last function, how to do the top of the element, that is called peak function. The peak function is always pointing to the top of that element. The top of the element is what? The index, first index. First, I want to, before displaying, I want to check priority is full or not. If it is full, it returns -1, or else it will take the top of the element, that is the item PQ of item 0 as to be written. See, if in case exam asks, write only the function of peak and only the function of NQ, only the function of DQ of priority queue, so you need to write down these functions. See, that will have that the priority. See, whatever I have to do, that we can do the main program. You can call either NQ operation, you can call any number of NQ operation or DQ operation. Say I'm in priority queue, I'm taking the PQ as in variable of that one. I'm doing with all the values inserted with 0, and all the elements of the queue I'm doing, I'm calling NQ operation. The first time I'm inserting 3, second time I'm inserting with 2, third time I'm inserting with 15, fourth time I'm inserting with 5. See, I'm not giving any order. I'm not giving in either in ascending order, I'm not giving descending order, but I am passing just only calling the NQ. enque is adding in element to the priority queue of PQ. It will store all those things. See, there is a one task. Assume after adding all 6 elements, I am calling deque function. All of you observe now. I am calling deque an item printed. So what deque function I am calling? Deque from the queue, deque of ampersand PQ. This is whatever I am calling deque, I have to remove the element from that PQ. See, what is the top of the element? This function I am returning for as a descending order, whatever stored. See, whenever I'm calling it is stored it in whatever the top of the element. Top of the element is always stored in the last, the less value has to be stored it. So when I'm calling the last less value, so the print the top item of the deque. So I'm calling for our enque operation. So this is stored it as the deque of PQ. The top element is stored as the less value. Among this 1, 2, 3, 4, 5, 6, which is the less value, the 2 has to be always stored in the top. See, because of that, when I'm calling the print function deque from the queue, then the answer has to be get 2 is dequed from the queue because 2 is stored in the top of the element. Okay, clear? Then can you tell me, when I'm calling one more function, top element is percentage D, peak of ampersand Q. What is the meaning of peak? The peak is the top of the element. What is the next top of the element? What is the next top of the element is stored it? The 2 is the first position as stored it. The next highest number compared to the 2. What is the next highest number? The next highest number has to be 3 has to be stored because compared to the 2, the next highest number is 3 because 2 is already removed from the stack. Then 3 has to be the top of the element. Can anyone respond? Whenever I'm calling the next deque element, so which element has to be deleted? Assume I'm calling one more printf function here. Which element has to be deleted? Any idea? How 4? I'm asking which element has to be removed from this, because I am calling here top element, but I am not remove that element. Okay, so see, first element 2 has to be removed, but I am calling only the top of the element for displaying. 3 is not removed from the stack. 3 is there in that. Then whenever I'm calling the same function once again here, then it will delete which number? The 3 has to be deleted from that one, not 4. If I call once again one more delete option, the next element has to be replacing by 4. See, that has to be removed. Okay, so that is how the priority queue is working. This is I am printing. So this will have a priority queue has to be ended. Okay. The next we have to be move about the linked list. See, we learn as of now, till now, there are different types of data structures. We learn array and we learn about the stack data structure as well as the queue. The queue have a linear queue, circular queue, as well as the priority queue, double-ended queue. These are the different types of queue we'll done it, how to do the implementation, all the queue done. So next we have moving to another type of data structures we call as a linked list. So most of the real-time applications problem can be implemented by using the linked list because it is also contain the address of the what is the next variable it is stored it. See, that is because of that we are using the most of the application linked list. See, we have whatever we already studied, stacks, queues, Radicate all those problems, all type the stack push and pop operation, queue, inserting and deleting operations that can also implementing by linked list. So you have a concept of the linked list. We have to implement stacks and queues by using circular linked list. The linked list we have different types also, but we need to implement stacks and queues by using either we can do singly linked list or by using circular linked list also. As per your syllabus, you can also have all the types. Stacks and queues can be implemented by using singly linked list as well as the circular linked list. What is the linked list? You should be know about. Please careful. So don't on and sit. See, this is very important. If you not listens today's class, you nothing will be understand about it. Can't able to write test. Okay, be careful. The list, a list is a linear linked list, can be defined as a collection of variable number of data items called nodes. We call as a one node. See, this is that. See, this is the representation of the two box we call as a node. List. It's a linear, can be defined as collection of variable numbers. There are different numbers. It will have a data items called nodes. We call node 1, node 2, node 3. Observe there are different types of node. See, the list are most commonly used non-primitive data structures. Each nodes are divided into two parts. See, observe. See, this is the node number 1. The node has divided into two parts. See, this is the two parts I am writing. What is the first part? Observe this one. What is the first part? The first part contains the information of the element. What actually entered that one? I am inserting 30 into that node. See, that is 30 is my information. See, if in case that link has closed, please rejoin the same link. Okay. Because it's showing 6 minutes, 40 minutes of the package, it will again rejoin the same link. The first part contains the information of the element and the second part contains the memory address of the linked list. See, this is the second part is the link. Then second part link will contains the address of the next element. See, the next node is 20. This 20, where it is stored? How can be searching? That searching address is stored in this link. See, that means the link, the list is have two parts. First part is called information of the element. The second part contains the memory address of the next node in the list. It is also called link part. It's clear? It is also called the link part. I have a start. The start will be addressing always the first node. Okay, the start will be indicate there is a 1000 address. From the 1000 address, it will be pointing to that information of the node number 1. As I have a 3 nodes, collection of nodes. How many nodes are there? 3 nodes are there. The first node is 30. This is the link address contain the 20. The second node value is 20. It contains the address of the next node is 10. The 10, I don't have any more node. The last is embedded by null. It is the ending of my node. That's the ending of that list. See, this is the representation of the list. See, I will stop my sharing the screen and I will end my link. Again, I will rejoin the once again for that. Everyone, please join the next link. Same link.